Party from my place. All right, let's get started. I think welcome to another session of learning Bitcoin sCrypt. Sorry, Bitcoin smart contracts. And yeah, actually, I'm very excited today to introduce something. Hopefully, will for some of you will be mind blowing today. So this is the first time I show this in public. So if you have any questions or comments, let me know. So how many people have just raise your hand, like how many people have already know sCrypt language before? Anybody?
Yeah, I do.
Okay, not many. Okay, no surprise. How many people know of JavaScript? Anybody?
I know.
Yep.
Okay, much more. Okay, that's great. So I think today I'm taking a little bit of a surprising time maybe for you guys. So I'm not going to talk about sCrypt. Instead, I will teach the whole course in a different language. Hopefully you are all familiar with. So the idea here is, I don't want all of you to learn a new language. Every time you do some language, right? However complex it is, it's still a barrier, right, for new people like you, most of you. And second, I don't want you to learn entire new set of tools because, again, right, every time you introduce something new, you just create barriers. But also, I want to have something, it's a fantastic developer experience. For example, you can have the best IDE support. You can also have all the, let's say, package management as well. So the answer to this is, not something new language, sCrypt probably you are expecting, but Typescript. So for people who have not heard of Typescript, the Typescript you can think about it's pretty much just JavaScript, but with added type information. That's most of it. I think there's maybe some minor extra needed, but that's in a nutshell, that's what Typescript is pretty much in the name. So the reason that we want to develop smart contract in Typescript is if you look at the graph I'm showing here, even though we say, hey, we are kind of in so-called the blockchain, Web3 or Bitcoin space, right? So if you look at the total number of developers in this, in this space, I think most people talk about Solidity. So you probably have only about who's fully familiar with this, about a little bit less than 20,000 people globally. But if you look at all developers, that's like a 3 orders magnitude, which is in the range of tens of millions of people. So it's pretty much like its own country. You have tens of millions of people. So at the beginning we have the so-called sCrypt language, which is even smaller than this. I think the latest downloads for our IDE is around 4,000 people. So compared to this, is 10,000 times smaller. So that's why we come up with this idea. So instead of having something totally new for developers to code the Bitcoin smart contract, why not we just leverage the network effect of none other than JavaScript. And TypeScript is, I would say it's very similar to JavaScript. If you already know JavaScript, you probably have no problem learning about TypeScript. You probably spend a few hours or even a day. So that, enables us to develop the new TypeScript framework, which we call sCryptTS. So basically, it's a TypeScript framework to enable you to write a smart contract that can run on Bitcoin. So the great benefit here is everything here you can see is just pure TypeScript. There's no, let's say, sCrypt or Bitcoin script. For anybody who has been in JavaScript code or even TypeScript, right? This is, I hope this is pretty readable. At a high, just at a glance, is this something pretty much readable even without much comment here? I would get some feedback from you.
Yeah.
I can see it. It's fairly clear.
Okay. All right. Yes. Yeah. That's at least some first expression. So from today on, we are going to teach how you write smart contract in this language, which is TypeScript. So the only thing we add is you probably heard about the so-called decorators, and some other language called annotations or text, whatnot. So you can play a little bit of you can pretty much add your own like a programming language features, new ones into existing ones by just adding this so-called decorators. You can modify its behavior. So that's exactly the mechanism we use. So I'm going to cover each section one by one, so you can get a full grasp of what is happening here. But overall, this is something I just want to get a sense. Do you want to code in this, or you want to learn something new, like sCrypt or even Bitcoin script? Anyone?
So Shao, let me ask you a question, please. By the way, my name is Usman Lakhani. I am same team as Cal. We've spoken in the past, Shao.
Okay.
So this is so you've wrapped sCrypt under a Typescript framework, and
yes.
So is this the sCryptTS has the same capability features as just the core sCrypt?
Yes.
Or are there
exactly.
things that got missed because of the wrappers?
It's functional equivalent. Just syntactically is you think about it, it's like almost syntactic sugar. So sCryptTS is equivalent to sCrypt. sCrypt is equivalent to Bitcoin script. So it just looks different, but underlying is all eventually it all ends up in Bitcoin script. So it's function is equivalent. A good question.
I see. The reason I asked because I've worked with other situations where we had wrappers upon wrappers, and eventually the performance degrades to the point where it becomes a little, questionable if wrapping it around more is. But you've answered my question, so please continue. Thank you for the answer.
Okay.
So is this actually a wrapper for sCrypt then, or is it a completely different?
So here, I mean, that's the internal implementation, right? For users, they don't know anything about it. They don't have to know anything about sCrypt. So they only play with TypeScript. So you can use npm, you can use VS Code to decode the work. You don't install anything else. It's pretty much just TypeScript. Okay.
Yeah, but in the background.
Yeah, in the backend, it's it hooks up with sCrypt. But the user, you don't have to know. I think because most of you probably heard about sCrypt before. So for new people, completely different web developer, they just come here to code Bitcoin smart contract. They don't even know sCrypt anything. They just another library, cool. So that's the whole idea. So at the beginning, I showed the principles of the design. So they don't have to learn new language, new tools. They have fantastic always developer experience. So that's where what it boils down here. And just for the record, this is the first time I kind of publicly talk about this. So as a as a bonus for this course, at the beginning I would think about teaching either in sCrypt or this TypeScript thing, but then I figured out, okay, probably most people you already heard, at least have some experience with its close cousin, if not JavaScript. If not TypeScript, you probably have some experience with JavaScript already. So, okay. Anything else here? If you don't know all the details, that's totally fine. I'm going to jump into all pretty much like a line by line and to talk about all the specific syntax here. Okay.
Could I ask one question?
Yeah, sure.
So the way that I'm looking at it right now, tell me if I'm wrong, but so basically sCrypt is a high-level language to Bitcoin script, right? So is sCryptTS. Yes. So if you're learning sCryptTS, there would be absolutely no reason to learn sCrypt, right? I mean, the sCrypt does in the normal contract language because it's a high-level language as well, right? It's not. It doesn't exist. It gets compiled down to the Bitcoin script. So what I'm saying is, if you learn sCryptTS, there would be no point in learning sCrypt. And it's all the functionality of sCryptTS. Are the two the two functionalities, are they exactly the same, or are we seeing an early beta or alpha or something like that?
Oh, at this moment, okay, first question, yes, absolutely. If you know sCryptTS, you don't have to know anything about sCrypt, so it's totally gone. Okay, so that's number one. Number two, and the functionality, I mean, in principle, is all the same. But since now we just release it, we still a little bit of a catch up to do. Finish. We have the kind of like a beta, but once we release the I would say 0.1 version, it will be exactly the same. The functionality, it will not be something you can do in sCrypt, or you cannot do in sCryptTS. It will be, these two will be totally the same. Whatever you can do there, you can do it here. Does this answer the question?
Yes, perfect. Thank you.
Okay, great. So I'm kind of like a, innovate to pretty much crush myself the previous sCrypt. So yes, that's the idea here. Anything else? Anybody? I guess this is the first time I talk about it in public. So if you have questions, interrupt me anytime. Okay. Okay, let's get into a little bit of the details. So here, first of all, if you know, know any kind of like a framework, probably at the beginning, you probably have to know all the data types. Here we have a basic data types. We have 3 types. So, big int. Okay, here's a little bit of maybe a little bit surprising because we're not using number, which is the default type in TypeScript to represent a number. Either it can be integer or it can be also, fractional numbers, floating numbers. The reason we choose big int is because there's a one-to-one mapping between big int and what the Bitcoin. In Bitcoin, down to the script level, right? That's eventually we are going to run. The number there is big int, meaning it can represent arbitrary length. So that's why we choose big int instead of number. So you can have other, you can pretty much also have Boolean variable. You can also have string. So this is the 3 basic types we support right now. But of course, later on when we go to, probably the next lesson, I'm going to talk about how you have composite data type like arrays or struct. But if you talk about the primitive data types, we have 3 here. And the only thing I think you have to notice, everything that when you talk about numbers, it's big int. So you can represent arbitrary length in integers. So that means first, there's no fixed length, like uint 32 or int 64. And there's no floating numbers. If you want to have floating numbers, you have to use some libraries, defined. A floating you have to use some other libraries. It's not come out of the box, but it's doable. We'll show you sometime later. Okay, any question here? Okay, I think this should be straight.
How would it be possible to use, for example, a 256-bit integer, for example? I mean, the big int is a 256-bit integer, right? Sorry, it's a 64-bit integer, right? So do you have to pass different decorators to that, or are these the only decorators that well, is the big int, is that the only specific type? What about all the other types? For example, the address. Oh, right, that's
okay.
That's what I'm looking for.
So that's okay. First of all, if you have some like let's say 64-bit number or 256, if you use a number, you can always fit in here, right? Because this is big int, so you can put any size number there. So second is, this is just primitive data types. So we also have something which is not primitive, right? But for example, hash, a public key, or what else? And some other like a private key even. Right? We have all these domain-specific types. That's not typical in TypeScript, right? We have so-called domain-specific data types. So we also support those as well. But yeah, I'm here. I just mentioned the primitive ones. Yeah, whatever you just mentioned, that like let's say SHA-2-fixed hash or Bitcoin address, which is also RAPMD 160. We also have support this domain specific data types as well. But these are not primitive. Primitive means it's all those types that underlie the types they're using these types, right? But they are not the same types. Make sense?
Yep. Thank you.
Okay. Thank you. Okay. Sounds great. Okay, data types, and the next one we're going to talk about is, of course, user-defined functions. You know, in like pretty much any language you learn, you know, if you have any kind of like a code reuse, you use one basic way is you write some functions, right? If you have some functionality you are doing again, you don't want to, you know, copy paste the full code every single time. So again, we have the function here is using this decorator called method. So then you have a function name, you have a list of parameters, and then you have the return type. It's pretty much the same with a normal TypeScript function, except, you know, instead of using function, the keyword here, we are using the method decorator here. So everything else is the same. You can, you know, this is the body, this is the arguments, this is the return type. Make sense here? I think this should be straightforward. But if not, let me know. Okay. So functions. Okay. Let's then a special type of functions we call the public functions. So public functions, as the name suggests, you know, it's again still using the method decorator, but the only thing is you have the public declaration here. So when you have a smart contract, you have two types of functions. One is public, the other is not. You know, without this, so when you deploy the contract, and then you call the contract, you can only call the ones that's declared as public. Okay, so you cannot call like the previous functions without this keyword public. They are pretty much like, you can think of like a private or internal. So you cannot send transaction to call this function. You can only call the so-called public ones. And the only I would think syntax you have to pay attention is this assertion. So I think probably most of you have heard about the assertion, right? In some other languages, even in TypeScript. So if you have assertion, it's pretty much it's a function that takes a Boolean expression, right? So if it's the Boolean expression evaluated to true, there would nothing, right? There would be, the program will just keep executing. But if it's false, then the whole thing will quit, right? You will either throw or either you will abort. The whole program will abort. So that is pretty much to ensure all the conditions are met, right? So if you remember at the very beginning, when we talk about, you know, the UTXO model and the smart contract associated with it is a function, right? So you have F in the locking script, you have X inputs in the unlocking script. So if f of x returns true, then you can spend the UTXO. So whatever that means, translate to here, if you run a public function and all the assertions pass, that means you succeed. But if any of the assertion fails, that means it returns false, and you cannot spend the UTXO. Okay, is it any question here? Anyone here? Okay. If not, I can keep going. So we talk about public functions. And if you look at the highest level, you know, we have smart contract. That's a base class. You can think about the parent class. Any actual smart contract, they have to, you know, inherit or extend from this basic class. So of course, then if you talk about any of a class, you can have a constructor. So constructor is just like any other constructor in TypeScript. So you use this keyword, and then you pass in your list of parameters, and then these are your properties, right? You have props, you want to initialize them, And the only thing you have to be careful, the only thing that you have to note here is the first statement in the constructor is always, you are always going to call super. So super pretty much just call the constructor for the base class, which is a so-called smart contract layer here. Make sense here? This is the only exception. Like just since you have to remember, whatever you put here, XYZ, you put super XYZ at the first statement here. Everything else is, you can write whatever you want, but at the first statement has to be super. Okay. Any question, comments here? Okay, seems good so far. So let's go to, look at the hello world. I think I briefly showed it before, and I'm going to walk you through this. So again, so any smart contract, Bitcoin smart contract right now, for example, you write a smart contract called demo, and what it does overall, basically you have two numbers, you're putting a UTXO, and then whoever who knows the sum of these two, they can unlock it. So that's what the spending condition is specified by this smart contract. So let's now look at how do you do it, how do you code it. Again, at the highest level, this smart contract, this is the class that exported through sCryptTS. So any class you want has to extend this smart contract. Okay. And then once you have the class, you can declare properties by using this decorator prop. Okay, so now here we declare two properties, X and Y. So both of type big int, the one of the three primitive data types we support. So here, for example, here you cannot write, let's say, number. It's not allowed. So if you really have number here, you can always pass in as a, you can convert the number into big int, right? Because big int, if you want to talk about integers, you can always put any type of numbers, integer numbers into big int. There's no problem. So once we declare properties, we can define, our methods. Methods. For example, here we define just a utility function. We just sum these two. So pretty easy, right? Pretty straightforward. We have two arguments here. We just return the sum by using the, add operator here. So lastly, and actually most importantly, we have the public function called add. It's going to pass in an argument, and we have only one assertion here, meaning if this input equal the sum of these two, properties. So if this is equal, this call is going to succeed. So a public function call succeed, in the Bitcoin world means, oh, you have successfully unlocked the UTXO, and then you can move the coins in the UTXO to whatever, you can produce the next set of UTXOs. Okay. Any question about this? This is pretty much, you can think about the TypeScriptTS hello world. This example. Okay, if no, that's good. Okay, that means it's not super hard to know about this. So if you have not noticed, so we talk about different data types, but we didn't cover anything about how you construct your expression, or how do you have different control flow, different kind of statements. So this is actually the benefit of using this framework. That means you just reuse existing TypeScript, right? For example, if you want to, let's say here, right? We just show here, if you want to add two numbers to, big int, even in a smart contract, if you want to add two numbers, you just reuse the same one. And if you return, if you use, if you define a function, have some return value, you can just return, using the same thing. Same here, expression, of course, you can also here using the, equal operator to compare two numbers. So that's no specific new syntax you have to know. Whatever TypeScript you already know or JavaScript, you can just reuse the same syntax. There's nothing new you have to, at least not much. I mean, just look at it. It's just to an outside person. It's just, if I don't tell him this is specific to Bitcoin smart contract, he can just see some TypeScript code here. And also, also have to know new type of statement. That's new syntax. So for example, if you want to do conditionals, right, you can reuse the if else, right? Or if you want to use, for example, for loop, if you want to use loops, right, you can reuse existing for. Okay, but of course, I think I'm probably in the next lesson I'm cover a little bit of some exceptions. So basically, some of the syntax you cannot use within this smart contract, class definitions, but everything here is pure TypeScript. So you can think about, sCryptTS is a so-called domain-specific language. It's a subset. It's a subset of TypeScript. So everything in sCryptTS is valid TypeScript, but not vice versa. I think in the first one, I just want to give you a high level, idea of what it is. So I'm not going to cover all this, the things you probably not allowed in. There's certain type of syntax. For example, while loop. While loop is not something we can support right now because, fundamentally the script is fixed length, and everything has to be unrolled if it's a loop. So it has to be static known. But if it's a while loop, you can depend on some user input. There's no way you can translate the while loop, absolute while loop. Maybe some specific cases, how many loops it's going to run, then you can translate, and then you can put in this, Bitcoin smart contract. That's just one type of exception. But for today, I just want to give you a high level, what it looks like, and get some feedback from you. So another thing I just kind of forget here. So if you notice here, all the user-defined functions, they have a return type. But for public function, if you notice here, I didn't write anything. So basically means it returns void type. So meaning you don't return anything because, when you call a public function, the Bitcoin space, meaning you're trying to spend some UTXO, it either success or not, it doesn't return anything to you. So actually the miners only can only accept it when it's true. So that's why we kind of just skip it, because it always has to return true. You can think about at the end, there's always a return to there. But just for brevity, we just omit that. Okay. Anything? I think that's just today what I'm going to cover, because this is very new. I want to have leave some time for questions and people to digest. This is something completely new. We have not talked about in public ever before. So I'm going to, this is all today I'm going to cover, and I'm just here to see what are your feedbacks, questions.
Just a quick question. So we can use can I use Visual Studio Code for using this framework?
Yes, fantastic. You just download Visual Studio, you're ready to go. So you don't have to install even another new extension, because TypeScript is built in with Visual Studio Code. And not only you can enjoy the language support, but you can even reuse the debugger. I think maybe in next week or something, I will show you how to. So in the following weeks, first I'm going to introduce more to the syntax and give you more complex examples. And then I'm going to show you how to write test. And then if the test fails, I'm also going to show you how to debug. So when you debug it, it's also just, you can use the Visual Studio Code, VS Code. You can use the same tools you're already familiar with. And you can even use console log if you want. So yeah, in summary, yeah, you only use Visual Studio Code. That's enough. You don't have to install anything. I mean, to use this framework. There's no other dependency. Make sense?
Yeah, thank you.
Okay, thank you.
I think I have some feedback actually. I think it's really great actually what's actually happening. One thing I would say that it would be really nice that if we could at a later stage get some kind of ESLint plugin for linting as well. And the other thing as well is I was thinking about the decorators that you're using. So are the decorators really necessary? Because wouldn't you know if it was a property or a method?
Okay, yeah, great, wonderful question. I think when we design it, we actually debate this internally, whether because from the look at it, you already have this, right? So you may think it's redundant to have this, right? Do you see what I mean here? Same page? Because you already have at the highest level, you already extend the smart contract. Wouldn't you know all these are like, these are properties, these are the methods? But here's the thing, right? So all these things, you can think about all this with decorated. These things are eventually they're going to end up in, so-called Bitcoin script and then end up on chain, right? But what if you have some almost like a stuff that's you will not end up on chain? For example, here, right? You may have a function that says, let's say you want to this is a simple example. Maybe here you want to say, hey, I want to have a z that's like the sum of the cubic for these two, right? Or let's say I want to print these two numbers I want to see. So all these things, then you can declare something that's not a property here without this decorator. For example, you want to have a z here, and then you want to print out this z, have a function here. So these things that eventually they're not going to end up on chain, right? So that's the philosophy we hear. So eventually, the big idea is we don't want to differentiate what is a Bitcoin smart contract, what's going to be on chain and off chain. We want to have the same code. No, we want to have all the code in the same place. We don't want to, if we don't have this, right, then you probably have to put this in a separate file, right? And then all the things in this file are going to end up on chain. And then what if you have some like utility functions, or you want to have some console logs, all the things that not end up on chain, you're going to write you're going to put in another file or another class, right? But these two are maybe very highly coupled. You see what I mean? So we want to have the capability to put everything together. That's why right now we are using the decorator approach. But that's why I want to get the feedback, right? But if a lot of if let's say 1,000 people use this, they all say, hey, it's kind of like a cubism. You have to type all these things, and in reality, most people that don't have non smart contract data or method here, we can also get rid of it. But that's just our initial version design. Yeah, I hope.
Yeah, great. I like it. I like it. It's pretty good. Thanks.
Okay, thank you. Yeah, very good insight. We actually have been debating this internally. Yes, because at the beginning I was thinking, you already have this, so I know this is my kind of. Why do you need this extra stuff? Why don't just, just get rid of it? But then I think some other team members, they are saying, hey, we want to put non-smart contract stuff. That will not be on chain. Hopefully when we get some to the bit more complex, I think I'm going to show you example in the future classes. You have sometimes you want to compute something very, very complex, and but it's still associated with this specific smart contract, but you don't want to end up on chain, right? For example, I'm just giving another hypothetical example. So what if I have a smart contract, there's how do you unlock it? Is that I'm going to give you a big number and you're going to tell me the prime factors, right? And then I don't know if it's big number, right? whatever, 120 bits or 256 bits. You don't know it's not easy to factor it. So I just want to outsource this to whoever can factor this number. You can take the money. But the guy who's writing the smart contract, he may not know the answer, right? And he doesn't want to compute to do the actual factoring, right? You may have a loop, right? To go through, from 0 to the square of n, right? If you want to factor n, you go from 2 to square of n. You want to find all these numbers. But then you can declare a function and say, hey, I'm going to write this big loops. It's probably going to loop from 2 to the power of 100. It's going to be huge. I don't want to put this, on chain. So it's not a public method. So I would still want to have a utility function. You can put it here, plug in. But this part, I'm only going to write it off chain. Yeah, I'm only computing it off chain. And then once I finish computing, I'm sending the transaction with this correct number, right? So this is just one example I could think of. But yeah, great insight here. What else?
So what other sort of
Can you get that? Okay.
So just wondering what other enhancements are you foreseeing adding to this framework?
What other enhancement? Oh, you mean for what we have from what we covered today, or from what we have
No, in general, you're going to be adding
okay.
more and more linguistic features, more what's the good word? Because use a good word for that. I keep forgetting. Syntactic sugar for other more complicated features.
I think for the syntax wise, that's pretty much fixed. And the only thing you can extend it is like any other framework or libraries, right? You are adding more so-called libraries on top of it. For example, if you want to do some kind of for example, zero knowledge, right? Then you have to rewrite, whatever we had before, right? For example, sCrypt, or nobody has written it before. So you have to rewrite all these libraries, right? Because this is now like a TypeScript, right? You can always, use an npm to publish it, and then somebody else can import it. So then the story is not to use syntax, because that's not necessary. The way you extend this framework and to have more people to use it is to publish more libraries, smart contract library. For example, you have your own, just give one example, right? You have a square, right? You compute this square number, or you can have your own zero knowledge. You can say, or if you have own, let's say fixed point, right? Because you cannot do floating point, so you may want to do some kind of a fixed point libraries. You can, but you have to code this in the new, using this, smart contract framework. You can then publish all the libraries in npm, and so other people can reuse your. It's like a JavaScript, right? So why is popular? Well, I think one reason is it's running in the browser as well. So the second is you have npm. You have a huge ecosystem, and pretty much all the functionality you can think of, there's something out there in the npm libraries. There are tens of millions of libraries you can go out there. So the way to extend this framework is not to add new syntax. I would imagine probably maybe some, but it's not going to be big. It's going to be writing libraries using this framework, so other people can reuse it. Does this make sense? That's how I see it evolve. Can you hear me?
Yeah, I can hear you.
Okay, great.
Yeah.
Anything else? All right, I think we can call it a day today here. And since it's something totally new, I'm going to give you some time to digest. But the number one reference you can go here is from our website to go to this link. And then we have all the tutorials there. We also have a setup, and we also have all the references if you want to look at each specific function, what is the signature going to look like? And I think pretty soon we are going to also open source it. So you can see, if you're really interested, you can see how it works internally. But if you just want to use it, you don't have to know that implementation. You can just go to the site here. No, it doesn't work? Really? Oh, maybe docs? Let me quickly check.
404, I get.
Wait, really? Oh, docs, sorry. I think let me send this here. I think I typed this, so I missed them. Okay, this should be good. Docs, sorry. Does it work now?
Works, yep.
Oh, okay.
Yep.
Yeah.
Thanks.
Yeah. Add a S. Yeah. Okay. I type it, so it's a typo here. Okay. Anything else? If not, I can cover more. How do you write the smart contract in this framework next time? From today on, everything is going to be TypeScript. All right. Sounds great.
Excellent.
And
Yep.
okay, great. Thanks, guys. Thanks for coming.
Thanks
Hope
for
to
that.
see you next
Thank
week.
you.
Okay.
Bye-bye.
Bye-bye.
Thank you very much. Thanks
Thank
a lot,
you.
Wei.
Have a good day. Okay.
You too. Bye.
Bye.